Hello everyone, welcome back to the second part. And as we have seen in the previous video, the instrument is not working. I don't have any output from the DC standard output, and moreover I don't have any live signal from the meter here. So before to go ahead with any further troubleshooting, I need to inspect if the meter continuity is okay, because otherwise will be very bad situation. So let's go ahead first with the meter check and see how it goes. To check the meter continuity, I have removed the meter drive bird, and I also have removed the two wires that goes they goes to the bird, and sadly it's completely open the meter. That is a very bad news. So before to give up, I want to remove the meter, open it, and see if we can have any luck that can be fixed. Once again, let's test the continuity. That open. So let's open it up. I have completely dismantled the meter and removed the meter scale. So I think I found the culprits, and I need to show you under the microscope. So let's try to do that. Okay, it will be very difficult to show you. However, the tiny wire that is shining in the middle of the dark area is the broken wire. Very difficult. So let me try a different way. Okay, you should now see the broken wire. Let me try to change the lighting. Yeah, this is the broken wire, and it is of course under there. So the task is to reconnect it. That is it's almost impossible, I have to say, but I will try the same. Unfortunately, despite all the efforts, I've been able to connect the broken wire over there. However, still open. So I think that there are more than one turn that is open, and so I can't save this instrument. By the way, looking at the service manual, the instrument, which has the center 0, is let me make some room here. It's reading 1 volt at the end of the scale, so from 0 to +1, 0 to -1 in all the ranges. And this is achieved by resistive partitor. So, well, of course, the original meter will be the right choice, but I am afraid that I have a very limited chance to find it one. So I will take the service manual and I'll show you what I have decided to do. As stated in the manual, when we have a full scale, either direction minus and plus, we have a 1 volt across this terminal, and through this divided network we have a path with, assuming that this is pointed in the center, of about 5 microamps each side. So perhaps I can substitute this meter for a temporary time with digital instrument, so I can use the differential voltmeter the same. in the hope that I will find in the future the original meter and mount back the original one. So let's go ahead with the troubleshooting of the instrument. The first thing that I want to make it work is the standard power supply output, and this is the setup. So let's power it on. Let's enable the output, and I should have 1 volt, and I have nothing. Let's see, on 10 volt range I have minus something, 100 volt minus 9, so it doesn't work at all. And those regulation seems to work. So let's see if I can trace back what's happening. The way that the reference standard works is to use a reference supply, which is an oven reference supply right here. The output is a pin 7. The floating negative side is pin 10, and the 11 is the ground of the oven circuitry. So the output this reference should be 5.9 volt, and so I have connected right to the output on pin 7 at the socket of the oven reference power supply, and see what it does. Let's fire it up. 5.9, spot on. So reference supply, it's working fine. So I need to see if it's passing through the voltage dividers, and I need to find a place where I can measure it, since it's somewhere here on those switches. So let me come back when I will find it. At the output of the dividers, I should have from 0 to 1 volt. Actually, it should be 0.999, since the knobs on the front panel are going to be all at 9. I am measuring right at the output here, so I'm pointing to this resistor, and look at that. And it's warming up, and it's climbing a bit the voltage. And I believe that if I will leave heating up enough time, I will reach, you see, it's rising up more. So this is very precise and spot on. So let's go ahead and find where the signal is interrupted. And by the way, it's quite a while that I'm looking around here where to measure the signal, I mean the DC, and look at that. It has just reached 0.999, and it's very stable over there. So very impressive precision and stability on this instrument. Very beautiful. Well, I came back to measure the output of the instrument, and I've noted that it was spot on to the 1 volt as should be. Then I change to by 10 range and back to 1 volt, and it's climbing. And I believe if I will leave, slowly will climb and reach the right voltage. I'll be back if will happen. We are almost there. Let's see. And look at that. It slowly has climbed to the right voltage, and it's spot on. Look at that, right at the output terminal. That's really weird. So it seems that the DC path as something that needs a lot of time to rise up. I don't believe is any capacitor since I have already checked all of those. I am just seeing a small drop, let's say 1 millivolt. However, let's see if this work. Yes or not. Yeah, not really. Okay, it's taking time also to drop down. No, it doesn't work. Perhaps the feedback path it's not doing its job. Let's try to see if I can trace it back. Well, I think it's actually working to some extent, because if I put at 0, so it will take some time to reach the point, but it's working. And perhaps if I increase let's see. Yeah, it's a bit out of adjustment, but it will take some time, but it works. Anyhow, let's see if I can find it. I have added 1 meter since I want to check the output level while I'm reading the input at the modulator right here. So before it is modulated, want to see if I have anything of strange. So let's fire it up. Well, actually, this is the output at the binding post, and this is the input at the modulator, which is the output passing through a network, which of course gives a voltage drop. While I was tracing the signal, the +1 volt, I found perfect here, and it was dropping right here and climbing slowly, exactly as the output. So with the removal of all the components around here, nothing has changed, and with the removal of the red wire from the modulator, I immediately have 1 volt at the end of the wire. So it was clear that the modulator was loading the signal, the voltage, and I have removed it. Nothing is wrong in the modulator, but I found the culprit. The modulator is not working since it's not easy to make you see, but okay, it doesn't focus. Here there is the neon lamp that has a broken leg, and this lamp should drive at 162 Hz the optic cells that are populating this aluminum block. I've been able to solder the broken leg, so let's see if it works. Okay, I have reassembled the bulb, so if I switch on, they should light. Yes, they are. So let's try to reassemble the modulator board and see if it works. Okay, I now switch on, and I now have the 4 neon bulbs that lives inside the modulator's units that are glowing, so they are working fine. The modulators are running, but unfortunately I'm having the same behavior. So this is the output, and as you can see, it's rising up slowly, and it behaves like vacuum tubes. Actually, we don't have them. So I believe that the problem lies in the amplifier sections. There are two amplifier sections, low voltage and high voltage or level section. I don't believe the problem is in the feedback, since I have traced it and checked for continuity and appear to be fine. So at this point, I think I need to study more in depth how this closed loop amplifier works, and then I will be back. So that's it for this video. Thank you very much for watching, and I hope that in the next one I will be able to trace the problem and fix it. So thank you again for watching, and see you very soon.